Hi, David. Great to see you again. I got a few questions for you if you don't mind. So I understand that you're one of the co-inventors of the 3D IPNS technology. Do I have that right?
Hello, Frank. Yes, you're absolutely right. I have this pleasure and actually honored to be part of this group that has invented the 3D IPNS technology.
Outstanding. Can you tell me a little bit about the history of the invention?
Absolutely. So the idea is of creating something with physical mechanisms of action was born in 2009 in the genius mind of Dr. Janusz Świętosławski, who leads the research and development department at ICB Pharma. This idea and the development work was related to the fact that our industry, and I think I can say the word globally, is facing with the same problems. That is the limited number of active ingredients. Saying a limited number of active ingredients, I'm thinking about the active ingredients that are coming from a new chemical groups. So having different mechanisms of action from a biochemical perspective. Another thing is the fact that for many years we were using pyrethroids, for instance.
Right.
And actually the treatment failures that we made brought us to a moment that most of these substances are no longer effective. So in 2009 we started to look for something that may become an alternative that also would not cause any regulatory issues, because developing new compound is also related to a long-term regulatory process. So we wanted to find something that will be effective, will sort out and address all of the current challenges we are facing with that I just mentioned, whilst at the same time would not cause so many regulatory problems. This is how we started to look for different substances, and the first actually species that we were testing with the new concept, they were aphids. So at the very beginning, the first idea was to have a product which is very effective against aphids.
Oh, great. So tell me, what makes the 3D IPNS technology so unique?
Definitely, as you mentioned, the technology. So it's a combination of a process that is called Zoll-Gel process with a very unique silicone that we are using in a formulation. The Zoll-Gel process is well known in a chemistry, and nowadays it is used also in a medicine because Zoll-Gel can be used for different type of applications, microencapsulation included. We found out that combining the silicone with a Zoll-Gel process, with Zoll-Gel precursor, we may mimic something that the Mother Nature developed millions of years ago. Now I'm thinking about the spider web.
Okay.
So we are creating exactly an artificial spider web. So when we look at the network, at the structure that is created by the technology, of course, in a magnification, we can see that the structure is absolute grid structure. It's a network structure which is fully permeable to the air. Why it is so unique? It is so unique because unlike regular silicone products, this product is fully permeable to the air. Of course, I don't need to explain that in crop protection how important it is not to disrupt the breathing process, the transpiration of the plants. Each leaf has a special structure on its surface called stoma cells that are responsible for the breathing of the plant. So having something that is blocking these structures, we may cause phytotoxic effect. So we may damage the plant. In case of 3D IPNS technology, we are completely sorting out this issue because the network mimicking the spider web is fully permeable to the air.
Okay. So to restate, so I understand being that it's completely permeable, it doesn't work as a desiccant. It truly, as if Spider-Man has hit that insect with the spider that immobilizes it, and that's what kills it, and it's not sticky or slick like other organosilicones. Once it forms that net, it just kills the insect, and since it's gas permeable, the leaves are able to breathe and doesn't cause any asphyxiation.
This is very much correct, Frank. At the very beginning, we weren't really aware of the real mechanism of action, so it took us at least 4 years of research work to understand properly how the product works on a different target organisms like crop pests, because later on I would be happy also to tell you about the different type of applications with this technology. But in fact, the product immobilizes the target species, the insect or mite. It does not intoxicate them. Its mechanism of action is related to inhibiting its mobility, so they cannot move. We've said that we are immediately stopping them or arresting their feeding and the further damaging process of the plants.
Outstanding. So now that we know how it works, what makes it, I understand that the product is super eco-friendly. What makes 3D IPNS technology products like Stik Kote and Pest so eco-friendly?
That's a brilliant question actually, because taking into account that the mechanism of action is not related to intoxication but to stopping the mobility of the pest, the product does not generate toxic residues. This is an extremely important aspect, especially that it addresses the currently supported strategy of bringing the food from a field to table. So we are moving to a moment where the food safety becomes our priority. So without toxic residues, without toxicant being applied onto the surface of the leaves or just introduced to the environment, we are becoming very environmentally friendly and with this environmentally sustainable approach. Because in case of regular pesticides, with living toxic residues, we are affecting also the non-target species, such as honeybees or other pollinators, whilst at the same time we are affecting also the other beneficial, like predator mites, for instance. So this product it's definitely a targeted approach. So we are controlling the species that is present on the plant during the treatment without leaving toxic residues. And this is important also for the users. This is important for the farmers, because let's try to imagine a situation where the farmer is having a contracted delivery or like within 3 days or 4 days, and during that time, pests will just attack his field. So in fact, he cannot use regular pesticides because of the residues, and the delivery time is too short, to meet the waiting period requirements. In case of Stik Kote, we don't have this re-entry period. It can be used. The product can be used anytime, anywhere, against any pest.
Oh, okay. So that's great. So workers can re-enter after the product's dry, and they don't have to worry about coming in contact with residues or hazardous chemicals. And then backing up a second to where you were talking with the honeybees, and it also sounds like as long as Stik Kote, Pest Kote is used within label rates, that you don't have to worry about honeybees or other pollinators that are very crucial to growing crops and the environment.
Yes, this is very much correct.